Hello, welcome to part 3 of the 1.9 notes for linear algebra. So where we left off, we were talking about T, a linear transformation, is onto if and only if the columns of A span the codomain. So that means the reduced echelon form of A has a pivot position in every row. And I've got some examples of this, but I want to wait and do that with you in class. But we'll do, so I just want to do some general examples in class, but we'll do some specific examples in the next few slides. And T's 1 to 1 if and only if the columns of A are linearly independent. Okay, so we have T, a transformation from the domain Rn onto the codomain Rm. Okay, so look at this. This is weird. A is an m by n matrix, correct? However, I have no idea why this notation is the way it is, but it's Rn by m, and I guess the n is domain and n is codomain. This times looks a lot like A, rows by columns. This is not rows by columns. This is domain, so this is where X exists in the domain, and M, that's the Rm is where the B exists. So X exists in Rn, B exists in Rm, and A is an m by n matrix as before. If T is a transformation from Rn to Rm, as always, then T's 1 to 1 if and only if Tx equals 0 has only the trivial solution. I want to look at this with you in person as well. However, you can think about if you have the identity matrix, 3 by 3 identity matrix, then if you have the identity matrix times X equals the 0 matrix, then obviously all of the components, all 3 of X have to be 0. Even if you had a 3 by 2 matrix A, where the first column is 1, 0, 0, the second column 0, 1, 0, and then you had AX equals 0, you would quickly see that both x1 and x2 have to be 0. Only the trivial solution exists. So those would both be where AX equals 0 if and only if X is 0, and those are both linearly independent columns. However, if you had 1, 0, 0 as your first column, 2, 0, 0 as your second column, and you did AX equals 0, then x2 would be a free variable. You'd have x1 is negative 2x2. But let's do that in person. Don't worry about that right now. Okay, so the ones I do want you to worry about. Determine if this matrix defines an onto linear transformation. Okay, so if you want to see is it an onto linear transformation, what you can do is see if the rows, each row has a pivot. So this row does not have a pivot, so it's not onto. Another way you can think of it is, here's your row reduced A. If you multiply that by by X, is there any way to get an X such that 0, 1 is your image? No, because this 0, 0, 0 times X is going to give you 0. So if I have my augmented matrix and I put B1 and B2 right here and here, B2 can only be 0. So right there, you know, B, unless B2 is 0, is not going to be a solution to AX is B. But it is. 0, 1 is in the codomain, just not in the range. So is this one an onto linear transformation? So in this case, let's back up a sec. Here, the first row multiplied by 2 gave you the second row, so that's why those were all zeros. But here I changed that 0 to a 1. So now what do you think? Yeah, so you take A and you reduce it to get two rows, both have a pivot in the row, and so all the rows are pivots. That means it is an onto. Would it be one-to-one though? That's another question. This is A. It is not an augmented matrix, it's A. Are all of the columns linearly independent? No. This column of vector 3 is equal to negative 3 times vector 1. So it would not be one-to-one. It is onto. Is this matrix one-to-one? So for one-to-one, we're looking at, are the columns linearly independent? Well, look right here. There's no way to have 0 transform into a 4. If you don't believe me, go ahead and do the row reduction and get these two columns. And since column 2 is not able to be a scalar multiple of column 1, we know they're linearly independent. However, is A onto? We would say no, because there's only a pivot in the first and second rows. Is this a one-to-one linear transformation? Hope you're saying no. Why would you say no? Because the columns are not linearly independent. Notice here, it is not an onto function either, because when you row reduce, you do not have a pivot in every row. And that is it. So good luck and see you soon. Bye-bye.